Hey everybody, this is Larry. This is day 6 of the Leetcode Daily Challenge. Day 6 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. Also, just want to say happy Diwali to people who celebrated. Yeah. Anyway, today's problem is single number 3. Okay. So I would also, two things. One is I stopped this live, so it's a little bit slow. Let me know. The second one is I actually, I don't know, I feel a little bit sick today, so if I'm a little bit foggy on my mind, that's my excuse and I'm sticking to it. Okay, so let's see. Given an integer array numbers in which two ones and other elements appear twice, find the two elements that appeared only once. Okay. So actually I know this one, to be honest. Because I do remember it because it is actually interesting. That's why I know it, I suppose. And maybe I'll have a link below on, because I've solved this on stream. I don't know how long ago, maybe a year, maybe longer than that, 2 years ago, maybe 3 years ago. So I'll put a link there or something like that, or someone can put a link there and I'll give you props. But so it's a little bit weird for this one for me to kind of like think about it, but maybe it's hard for me to demonstrate like, oh, I don't know this one. Let me start it from scratch because this is very unique. I would say doesn't really come up that much, to be frank, but I will try to do my best here to kind of explain it better than my other video, because the other video maybe I was just more about exploring and solving it, where now I know the answer, but I'll see if I can explain it. Okay, so yeah, so one key trick. So one thing that I would know is, let's see. There is the easier single number. I don't know which one it is, but this is a well documented trick. If you don't know it, you don't know it. I wouldn't feel that bad about it. It's almost trivia in that, like, it's just something that people know because people asked it on previous interviews. I think back in my day, this was not a commonly known thing, so it was more interesting to ask as an interview problem. But I feel like these days, if you only get asked these kind of questions if you get someone who's way out of touch, or just, I don't know, maybe they discovered it the week before and like, oh, this is a cute problem, maybe ask on an interview or something like that, because there's really no value in it per se. Now that for me, like, I would never ask it. Well, I never asked it before, but I would not ask this as an interviewer in the future. So yeah, so the key thing to note is that any number XOR itself is equal to 0, right? And one thing I would say about bitwise operations, and I guess this one doesn't actually core to it, but if you think about bitwise operation, the one thing that I would say is that think about all the bits independently, right? Because basically we can separate all the bits by themselves, so then it makes, and if you're able to think about it that way, it makes these kind of problems easier, because no matter what, or like, doing operations on these things do not change the other digits, right? So that's one thing that I would say. And now, so maybe through this idea, we think, okay, what do we get, right? Well, the two numbers that appear twice, or sorry, two numbers that appear once and one number that appear twice, right? So that means that if we put XOR everything in their way, what do we get? We get, so we have, I don't know, a sub 0, a sub 1, a sub 2, dot, 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 a sub n, right? You go to some number z. And a lot of these cancels out because it appears twice, and we have this identity, which maybe you just have to know or play around with. So then now you come up with two numbers that only appear once. So you have x XOR y is equal to z, right? So this is what we get when we XOR the entire thing. And then the question is, well, we know something, right? We know that z cannot be 0, because if z is 0, that means that x is equal to y, which I guess would not, it's guaranteed that that's not the case, because otherwise, I don't know, that's just a very funky problem. And obviously it has infinite solution as well. Or maybe not infinite solutions. But I don't know. Maybe no solutions, depending on how you want to phrase it. I think that's more accurate, actually. I misspoke. But in any case, so we know that z is not equal to 0, right? So then what does that mean? That means that z can be represented by a binary number that is the result of all these XORs, right? And that means that as we said, all these numbers or all these bits, you can think about it independently of each other, and that means that for every, well, that means that if z is not equal to 0, z is not equal to 0, that means that this will contain at least one, right? That means that they differ in one place, so otherwise that's a 0, right? So then now let's just kind of remove all these things, and then now let's just focus on one of them, right? Let's just say we look at this digit and only this digit, even though there might be other ones. Well, that means that x, the y, at least in this digit, in the fifth digit, I think, or depending on how you want to count it, but in the fifth digit is equal to 1, right? That means that now you can think about it as, okay, that means either x is 1, so this is one of these two cases, right? Yeah, obviously. So then that means that here, if we XOR everything, and yeah, how did I want to go with this? Sorry, give me a second. I am solving the, or even trying to figure out how to explain this live. So, so I'm trying to find a way to kind of be clear about it. And it is a skill as well, obviously, because if it's not, then, well, I would not be good or bad about it. It would just be, right? But in any case, yeah, so that means that now, if you go back to this formula, now we look at every number, right? And how do I want to think about this? Well, there are a couple of ways you can think about this, actually, I guess. But the way that I'm thinking about it now, and to be honest, I did not remember, or do not remember the solution as much as I thought I do, actually, I suppose. But the way that I would think about it is, okay, there are a couple of ways to do this, right? One is that if you look at all the, let's say we focus on, I don't know, one of these being 1s and 0s. It doesn't matter, right? This is commutative, so for all effects, this is the same. So that means that if we take all the numbers in the nums list that is 1, by definition, well, I mean, okay, maybe let me step one second back, which is that, okay, let's say now we have, you know, we only look at this digit, or the fifth digit, say, just as an example, and you have something like this, right? Dot, 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 whatever. So it's just like, you know, you have n digits or n numbers, and each of them, this is the digit in that, or this is the value in that digit, right? And in this case, we always said that this is going to be 1, and this is just because, this is just by definition because we looked for it, right? So we find a case where this is true. And then now let's say we do, you could call it a bucket sort or just regular sort, it doesn't matter. Now you can sort it by something like this, dot, 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 and then at some point, obviously, there'll be 1, right? So you have something like this. And of course, now you can see that all these zeros cancel out, right? For at least for this digit, all these zeros cancel out. Or not cancel out, they just don't have any impact. It doesn't matter whether they get canceled out. Where everything on the right side here, everything cancels out except for 1, right? So then now, and this part may be a little bit tricky in that, okay, now that means that we could get rid of these numbers with no impact on the value, so that now we only look at the numbers where there's a 1 in that value. And then now that there's a 1 in that value, we think, okay, now you bring it back in, and if you only look at, and also, wait, sorry, let me step back just a second. So now that we have here, right, one thing to note is that in this case, let's say y is 1 and x is 0, just for whatever. This part, so x is here, right? And then on this part, y is here. Oops. So that means that this is x is here and y is here. So that means that by getting rid of this half, we know that y is in here and here by itself, right? And then now we kind of bring all the digits back together again, which is that if we kind of make this a multi-digit number, for every subset, because now x is in the other half, this just reduces to the single number, the easier single number problem of, okay, every number here has a double except for one number, and that is y. So then now we can just do this to figure out y. Right? We can figure out y from here. And here now that we can figure out y from here, we can just take it, like we have this formula, and therefore, and yeah, I mean, I'm not gonna prove this too much, but this is just, now you can figure out x is my point. And that's pretty much the idea behind this problem. Let me know what you think. I spent some time on this because I think it's a cool problem, but just not, it doesn't come up that much, to be honest. So depending on how you want to figure it out. But I think I figured this out by myself, and to be honest, I thought I remembered this more than I did. So I did kind of figure out how to explain it even, right? Like for this part. So I think hopefully that's cool. So yeah, so now let's implement this. So XOR sum, let's say, let's just do this one. With 0, so then now for x in nums, XOR sum, we XOR x, right? And then now we know that XOR sum cannot be 0, so then now we find a digit where that is the case. So digit is equal to 0, while XOR sum and one digit is equal to 0, we increment. So this is going to be true for some digit. And if you have doubts about that and you worry about things, then you can just do something like this. Greater, not equal to 0, I suppose. And assert that, I guess there's no assert here. You just run an infinite loop if your assertion is false. But so here you may just have a mental note of, okay, this time limit exceeds, it's probably this part, and I was wrong about something. But yeah, and then now we do the loop again. If x, you may notice that I love adding a lot of parent on my bitwise operations. The reason is because if I don't, I don't know, I'm always really bad at order of operations for these things. Well, I mean, I know how it is, but I don't want to think about it, right? Like, I mean, it's not hard to know it, but I feel like I mess it up enough times that, just have one consistent way of coding, and even if it's a little bit verbose, and in this case, it's not even that verbose, it's just more clarifying if you ask me, it makes your life a lot easier. Yeah, so here we have y to the x, maybe using x, and here is not okay, let me change this up a little bit just so that it's slightly less confusing with respect to the things that we talked about. Right, and then now we have, so x is equal to XOR sum of the y, and then now we can return xy. And that's pretty much it. I hope this is right, because if it's not, then that'll be a little sad. Oh, there could be negative numbers. Actually, I didn't know that. Let me think. That may be wrong, actually. Or I don't know if it could be wrong, but I also have a typo. But I have to think about that a little bit, because the bitwise operations of negative numbers are a little bit weird, maybe. Or like in Python, I always feel like there are always random surprises that I'm like, this is not how any other languages does it. But yeah. But it seems like it handles it okay. I don't know how to feel about that. Let's actually add this, but except for make this negative. Because now the XOR thing is a little bit awkward, maybe. I guess it still works. I mean, without getting too much about 2's complements and stuff like that, and XOR sum would still be positive in this case. Well, in this case, but not always, right? So if we had written this, we would be wrong because technically, I guess this would be negative, right? Because this would fail, I think. Oops. Negative numbers is actually interesting. I didn't think about it that much, to be honest. See, this would give you an error, and you'll be like, oh, now my assumption is wrong. I have to figure out what to do. And then the other one that I want to do was, yeah, okay, this, I suppose. Because then now they only differ from the sine. Oh no, because of 2's complement. So that's why. I guess I was wrong in. I mean, I do understand it if I think about it, but I think I was too hastily to kind of prove to yourself that something is in. Because it is easy to prove yourself like, oh, it should be obvious, but sometimes it's not, or like you may be right for the wrong reasons, and it leads you to trouble down the line. So sometimes it's worth thinking the time. But if you have questions about this, just think about 2's, or not think about, but Google up 2's complement, and that should kind of give you an idea. Okay, let's give it a go. Let's give it a spin. Yeah, apparently I did it. Wow, this time flies. This is 2 years ago in C. When I first started doing this channel, I did a lot of random things in C because that was always my most familiar thing. But I've kind of, you know, obviously did different things over time. But yeah. Anyway, that's all I have. Oh wait, let me go over the time first. Of course, this is linear time. Kind of, but yeah. Because this depends on the number of digits and stuff like that, so it's a little bit awkward to say linear in that there are actually 2 variables. This is n, where the number of elements, and maybe something like d, where is the number of digits, and in this case this would be O of n times d, I guess. Because in this case, you can say that this is O of nd, this is O of d, this is O of... also, I should have cached this. If you want to think about this as d, this would be an optimization. But anyway, this is also O of nd, because for every XOR, it's O of d, right? Because this is O of d, because... I mean, I know that there are computers or CPUs that does this as an operation, but... and especially given that it's a primitive, but you want to generalize it. So yeah, and in terms of spaces, this is O of d, where d is, of course, again, the number of digits, because that's the space needed to store d XOR sum, this digit number, and y, right? So yeah, so this is space. And of course, given that d is a fixed, you know, it's a fixed with primitive for int, I think, yeah. So therefore this d is, I guess, 32 or something like that. So that's why it is quote unquote O of n and O of 1, but it depends on how strict you want to get. Anyway, that's all I have with this one. Stay good, stay healthy, to good mental health. I'll see you later, and have a great weekend. Bye bye. Oops, didn't press the button. Bye bye.